basic design of how the Follow Me bot will work is a person carrying a phone will have the phone make a call to a web server on the Raspberry Pi to provide the current GPS location and heading. We will call this phone the master. On the Follow Me bot will be another phone that also calls the same web server to provide the robot's current GPS location and heading. We will call this phone the slave. For this video, I want to cover how the phones will call the web server and provide location and heading information. Since I have a couple of Android phones, I decided to target Android as my platform. To make this quick and easy and stay within the Microsoft development stack, I decided to use Xamarin for Android as my development platform. For those not familiar with Xamarin, it is a C# development platform that compiles into a near-native app for phones. The inputs needed for this app are the IP address of a web server on the Raspberry Pi, is the phone a master or local, the GPS coordinates, and the current compass bearings. The outputs are mostly informational and will be a web view to display results, a flag to indicate master or local, is the app waiting for the GPS to initialize, and what did the Raspberry Pi respond with? Let's look at some code now. I created a new Xamarin web project in Visual Studio. Create a new project, expand Visual C#, and select Android, then select the Web View template. In my case, the phone I'm using is older, and I need to change the debug target to support Android Gingerbread or API 10. We first need to add two using statements, Android locations and Android hardware, then inherit from two additional interfaces, the location listener and the sensor event listener. Let's focus on the location listener code to start. We need a couple of variables to get things going. A location manager object is needed to get location's provider object. A location provider is a string that contains the name of the location feature needed for GPS. Next, we need to initialize the location manager on the creation of the app. We start by getting a reference to the location manager. We need to get a list of location providers known to the phone. In our case, the GPS is always the first location provider, so we will cheat and just grab the first one. We need to add another using statement, system collections generic, for the iList. Lastly, we implement onLocation changed event to get the actual GPS coordinates. In this method, we want to start by making sure some location data was sent. Then, as we will discuss later, based upon a selection of master or slave, we want to call the Raspberry Pi at a specific IP address and static port. The destination page will either be an indicator as to whether we are the master or the slave. The query string will be the latitude, longitude, and bearing. We send the last compass bearing at this point because we need to know it when the location changes and not so much when the compass bearing changes. It also just makes things easier to do it here. We will display the results in a web view, so we execute on the main GUI thread to load the URL from the Pi we built and display the result of the last web call. Let's add those undefined variables used in this section now. We need one variable to indicate the user made a selection, another to indicate if the app is running as master or slave, and another to hold the IP address of the Pi's web server. Lastly, we will need to fulfill the contract for our interface. We do this by providing overrides for onResume, onPause, onProvider disabled, enabled, and onStatus changed. In onResume, we tell the location manager that we want to receive updates for the GPS and onPause to stop receiving updates. The remaining events won't be used in this example. Next, let's look at how to get compass bearings. Compass bearing comes from the sensor management object, so we need a sensor management variable. Since we need to store the last compass bearing for use later, I added a compass value class and an object variable. We already added the required using statement and interface. Compass values is a class we will create in a moment. A sync lock object is recommended to be used when getting the compass values. Next, we will need to initialize the sensor manager on the creation of the app. We start by getting a reference to the sensor manager. Since sensor manager is an interface, we need to fulfill a few more things. We primarily need to know when the compass values changed. We do this by using the onSensorChanged event. In this event, we want to check if the sensor type is orientation, which is the compass. We spin up a sync lock if we can, then transfer the compass values to my compass value object. We also need to implement onAccuracyChanged method to fill the interface contract. Lastly, we need to circle back and update the onResume to tell the sensor manager that we want to register to listen for updates for the compass, and on pause to unregister listening for updates. That was the meat of the app. We also need to finish the web view to get some user input and display results from calling the Raspberry Pi. I used a web view to make things more interesting for me. You could just as easily have used a form and an HTTP object. The template added most of the code we need to use the web view. We just need to make a few changes for our needs. First, we need a web view object variable to store the instance of the current web view for later use. Next, we need to change the initialization of the web view on the creation of the app to store in our global handle. Removing the var declaration will do the trick. We initialize the Razor template model and assign the first text to be displayed and a default IP so that the user can change the IP address to the web server. Next, we replace the code from the var parameters to the return with this code. This code further parses the query string and allows us to get the user entered web server IP address. In addition, it checks to see what button the user pressed. It was passed back in the method resource so that we know if the user selected master or slave. We then format a text string to load back into the web view that confirms what the user selected and informs them to wait for the GPS to initialize. Of course, we need to then load the string using JavaScript into the web page. We need to update the Razor model to add in our IP address field so that it is accessible by the Razor view. We also need to make a change to the default JavaScript invoke C# with form values. This code replaces the existing hybrid C# callback and allows us to return values back to our hybrid handler. Lastly, we need to update the Razor template itself. We change the text field to allow the user to input the web server IP address and add two buttons to allow the user to select master or slave. Again, when this page is submitted, the buttons using the onClick handler invoke the invoke C# with forms value method. As a final step, we need to grant permission to our app. We do that by adding these user permission statements. To put the web server into context, when the user selects a button on the web page, the JavaScript submits the web page to the should override URL loading method. This method parses the query string we built in the JavaScript to get the value of the IP address and what button the user pressed. It also posts back to the web page what the user selected and a message to please wait for the GPS service to start. Finally, when the GPS service does start, we should get an onLocationChanged event for the location services. As mentioned before, this routine takes the master and the slave settings, the latitude, longitude, and compass bearings, and uses it to call the web server on the Raspberry Pi. The result from the web server call are displayed verbatim in the web view and thus do not invoke the Razor template.